Find a possible solution for f of x given that f of x is integral of x e to the 2x. Okay, so this is going to be integration by parts. First thing we look for though is substitution. So substitution is usually the easiest way to go, and integration parts it's a little bit more cumbersome, a little bit more difficult, and best avoided when possible. So if this is like e to the x squared, then you see the x squared, you see the x, be like, okay, one is a derivative of the other, substitution. Alas, that is not the case, and we are not that fortuitous. So, integration by parts. And the way I start integration by parts is the inverse of the product rule. So I write out the product rule. This is basically a derivation of the integration by parts. So if uv prime equals uv prime plus u prime v, rearranging this slightly, we have uv prime equals uv prime minus, which one am I forgetting? U prime v. There we go. And so then we'll take the integral of everything. Whoop, change colors. You don't actually have to change colors when you're doing this yourself. So we have integral u dv equals uv minus integral v du. And this is the formula for integration by parts. Now the next thing to kind of remember for integration by parts is you want to know what to choose for u and what to choose for v. So you usually want to choose the thing for u that'll disappear, the thing that'll go away. The acronym or memory aid or general kind of guide in which direction to go in life is ILATE, I-L-A-T-E, where I is inverse trigonometric, L is log, A is algebraic, T is trig, and E is exponential. So the big takeaway from this mnemonic, and this is how you choose your U in your integration by parts, you want to choose, if you have inverse trig or logarithmic, like an ln of something, then you probably want to choose that. That's like your first go-to. Algebraic, yeah, okay, maybe. You're kind of indifferent. It works, but not the easiest. And then best, if possible, is to avoid trigonometric and exponential, because those don't go away is the big thing. When you take the derivative of sine, you get cosine, take derivative of cosine, you get negative sine, and it just kind of cycles around like such. And then exponentials, you take the derivative of e to the x, you just get e to the x, and that continues to cycle as well. Sometimes it works out. It's usually fairly difficult and not worth the effort. Okay, so we have algebraic in this one. So we're going to use x. So, green. I'm going to say that u equals x dv, so this portion right here, u dv. dv will then equal e to the 2x. v will then equal e to the 2x divided by 2. You could actually find that by substitution if you wanted to go through it. It's simple enough that you can kind of just do it in your head. And then du will then just be dx. Derivative of x is 1, and then you're left with a dx. So then we use the formula that we have. Orange is just too bold for me, too angry. So then we have u, which is x, times v, which is e to the 2x over 2, which we found. And then we subtract off the integral of v du. So e to the 2x over 2 dx. So there, du. This gives us x e to the 2x over, scroll down, take a better look, 2x minus e to the 2x over, so the integral of e to the 2x, as we did earlier, is e to the 2x over 2. We already have a 2 there, so we will get 4. And so here we can also, a little bit more than I intended. We get e to the 2x that we can factor out. And we will have, where is it divided by 2x. I think that's just supposed to be over 2. X e to the 2x, that's u times v. Yep. That's a superfluous x, unneeded. So we have x over 2 minus 1/4. It also might be e to the 2x over 2 x minus 1/2. There you go, make that into a minus. There we go. Okay. That seems reasonable. Let's take a look and see if that is where we want to go. So we have possible options here. Boom, 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 boom. Ah, right here, right here. This is it. So it'll be the first one. Nope, not a straight enough line. Savor the moment. Bam. So our answer will be the first one. Find a possible solution, f of x, x e to the 2x. So to backtrack, kind of go through our thought process here, we're like, okay, look for substitution. Substitution doesn't work because you can't find one thing that's a derivative of the other. So we're like, okay, if we take the derivative of these two things, x and e to 2x, enough times, will one of them disappear? And the answer is yes. X will disappear after the first cycle, iteration. And so we're like, okay, maybe integration by parts. We use ILATE as our kind of mnemonic to remember which one we should try first. We find Algebraic is the most senior, more senior than exponential. So we're like, all right, u equals x, do the formula, which we found the formula through the product rule, which we just reverse engineered. Plug everything in, work it through, and bam, get our answer. E to 2x over 2 times the quantity x minus 1/2. That's how you do this one. I will see you on the next problem. Thank you much.